dissociation equation for some different compounds here. Okay, so the first thing that we're going to do is we're going to start off with lithium hydroxide. We need the formula for that. So we will write Li is +1, hydroxide is -1, so it's LiOH. Now, the second thing to do is identify, is this an ionic compound or a molecular compound? Well, if the first element is an ion, or a polyatomic ion, or metal, it's an ionic compound. So, what ionic compounds do is if you were to take some solid lithium hydroxide and put it into water, what it's going to do, it's going to break into its ions. That's called dissociation. So it's going to form lithium, and you would put a +1, okay, because you got to show that it's an ion, plus a hydroxide ion, which is hydroxide is OH -1. Okay, that is how you would write a dissociation equation for lithium hydroxide. Now, you should show that it's aqueous, that it's in solution, and one thing, the charges have to balance along with the atoms, so you have to balance these equations just like a regular chemical equation. I'll show you in the next example how that would be a little bit different than this one, but the charges have to balance along with the number of atoms. Okay, so let's try ammonium sulfate. So the first thing is we write the formula for it. So ammonium, which is +1, and sulfate, which is 2-, so the ratio is going to be NH4,2SO4. Oops. Now, okay, so let's say that's a solid. Okay, now, if you put that in water, okay, what's going to happen is it's going to break into its ions. Okay, so it's going to break into ammonium ions, and they're going to be +1, plus sulfate ions, which are 2-. Now, one thing that you need to do is you need to balance this equation. Alright, so if you look at ammonium, NH4, we have 2 of them over here. So you have to put a 2 right there. You should also put that they're aqueous because we dissolve them in water. Alright, so you should balance the equations and then check, does this equation balance in terms of charge and atoms? Well, there's 2 ammoniums, 1 sulfate, 1 sulfate. 2+ and 2- on this side makes 0, and the charge over here is also 0. Okay? So, ionic compounds break into their ions. Okay, let's do sucrose. So sucrose is C12H22O11. Alright, now, when you put solid table sugar in water, okay, this is not an ionic compound. This is a molecular compound. Molecular compounds don't dissociate into ions. Okay, it's only going to dissociate into, well, it's not going to dissociate. So it's going to just break down into smaller particles when you put it in water. So there will be no dissociation here. Alright? Now acids are a little bit different. So sulfuric acid is H2SO4. That's the formula for it. Right now you don't need to, we'll tell you the formulas for the acid. But here's what acids do. They're interesting. What they do is when you put them in water, acids produce hydrogen ions. So it's going to produce an H+ ion here. Alright, that's what makes it an acid when it produces the H+. And it's going to produce a negative ion. In this case, it's going to be HSO4 -1. Okay? So this H+ is what makes it an acid. Alright? Now you should also make sure that everything's balanced here, but it is. With acids you just take off 1 hydrogen, like that right there. Okay? If it was something like let's just say if we had phosphoric acid, which would be H3PO4, okay, so to dissociate H3PO4, you just take off 1 hydrogen, so you put a plus there, and then you have plus H2PO4. Now because you've taken 1 hydrogen off that, it becomes negative. Alright, so I should probably show that these would be aqueous here. And I forgot to do that down here as well. But anyway, here's the moral of the story. You break things down into ions, Okay, you have to make sure that the atoms balance along with the charges on both sides. Ionic compounds dissociate into ions. Molecular compounds do not. Okay, molecular compounds just break down into smaller clumps of molecules, I guess, when they dissolve in water. Okay? Or the molecules get surrounded. The molecule does not break apart. Okay? That's it.